So, okay, our third talk is neutral duplicate question detection without label training data, and presented by Andres from TU Darmstadt.
Yes. Good afternoon. So my name is Andreas Rückle, and I'm from EKP Lab of TU Darmstadt, and today I'm going to present our recent work on neural duplicate question detection without label training data, and this is joint work with Nafisa Mousavi and Irina Gurovic. So why do we want to detect or find duplicate questions? Well, there exist a lot of already answered questions on the web, and this is particularly the case for question answering or community question answering forums such as Stack Exchange platforms. And naturally, we want to reuse this knowledge in a meaningful way. For instance, we could use this data to automatically answer repeatedly occurring questions with existing answers. Or we could try to avoid having the same questions in a CQA forum over and over again. So duplicate question detection can help us here to find other questions that ask for the same information. Let me show an example. So we could have a question that asks, should I disconnect my MacBook Pro's power cord when the battery is fully charged? And actually within the Ask Different forum of the Stack Exchange platforms, we have another question that says, can I keep the MacBook Pro's Retina power cord plugged in at all time? So both of these actually ask for the same information, and therefore both are duplicates. And when the right question already has an answer, we can probably also reuse this for the left question. It's particularly important for this work to see that often those questions have titles and bodies. So where the title gives a short question, the body elaborates on that and provides the scenario of the user and the problems he or she might be facing. So in this work, we make extensive use of the relation between title and body. When we would train models for duplicate question detection, the typical setup would be to use labeled training data, labeled duplicates, and then we can track classifiers or maybe question encoders. The problem is it is very expensive to obtain such data, because this is either done through crowdsourcing or by very active forum members. And therefore, because it's so expensive, most of the CQA forums actually do not contain enough labeled duplicates, and here's just a small selection of those. This is a known problem in the domain, and there have been previous approaches to tackle this. For instance, autoencoders, weakly supervised training with question-answer pairs, where we replace annotated question duplicates with question and accepted answer, or domain transfer and adversarial domain adaptation, where we train a duplicate detection model on one domain and transfer this over to another domain. Unfortunately, all of those have a couple of problems or certain problems in the one or other way. For instance, autoencoders are representation learning only, and they typically yield a rather low performance in this scenario. Weakly supervised training with QA pairs requires labeled accepted or good answers, which is not always the case and not always present in sufficient quantities. And adversarial domain adaptation still requires labeled duplicates from a sufficiently similar source domain. So if you would try to transfer from a technical to a non-technical domain, typically the performances drop substantially. So what we need is we need methods to train duplicate detection models without labeled training data that in an optimal world would achieve comparable performances to supervised training. And in this regard, we had a couple of ideas, and in this work we investigate two methods that only rely on the title-body relation. The first is duplicate question generation, or DQG, and the second is weakly supervised training with question-title-body pairs, or WSTB. So duplicate question generation. Our idea behind this is based on the observation that titles usually give a short question and bodies provide additional details on this question. In this, often the information is paraphrased. So in the body, the user or the person that asked the question uses different wording. In the body, additional information is introduced, and some information from the title might not be repeated. This is actually quite similar to real duplicate questions. So this can also be seen in our previous example, where in the body it is repeated, MacBook Pro is repeated, charger, but not battery or power cord. So what we do in DQG is now we take the body and we generate a question, new question from the body. For instance, can I let my MacBook Pro in charge long term? So if the body already has similar attributes to a duplicate, this generated question likely inherits these properties, and we could treat it as a noisy duplicate to the title. And this is what we use for model training then. Of course, we need to obtain a question generation model now, and we do not want to rely on additional labeled data. So what we do is very simple. We train a model to restore its own title from the question's body. So by this, the model should learn what is the topic of the question, what is most important in the body, how do titles or questions usually look like. For this, we can use any sequence-to-sequence model, and we experimented with a transformer sequence-to-sequence model and MQAN. MQAN is a model that was initially proposed as part of the natural language decathlon. And the most important difference here is that it also contains a copy mechanism which allows it to copy directly words from the body to create a new question. And because this performed a little bit better in our case, results in this presentation are only with MQAN. So the advantages of this method is it does not need any labeled training data. It can be used to generate a lot of duplicates. However, we need a separate question generation model, which is additional effort. In our second method, weak supervision with title-body pairs, we take this one step further, and we basically directly copy over the body. So if title and body, again, have similar attributes as duplicates, we could also just treat the body as a noisy duplicate to the title itself. Now the text lengths are different, so the body is much longer usually, so the model, duplicate detection model, needs to be able to handle this somehow. The advantages of this are it does not need any labeled training data. Again, we can use a lot of unlabeled question title body pairs. We do not need a question generation model. However, the duplicate question detection model now needs to be able to handle long texts. These are the two methods we propose in our work, and let's turn to the experiments. So what we did is we evaluated various different training methods in different setups. In this presentation, for clarity, I only show experiments with BiLSTM on 4 Stack Exchange data sets that were part of a work by Dar Shah from last year's EMNLP. And what this does, it learns question representation and compares them with cosine similarity. Importantly, we use their code, data, and embeddings, and the only thing that changes is that in the training sets we replace annotated duplicates with generated questions or title-body pairs. This allows us to directly compare it against adversarial domain transfer because this was the main contribution of their work. The data sets come from 4 technical Stack Exchange platforms, and the number of trained dev test instances count only the number of questions with duplicates. So because every question also has 100 unrelated questions in this data set, the number of training examples is much higher. Importantly, the authors of the data sets were not able to create a training split for the Apple and Android domains just because they don't contain enough labeled duplicates in their forms. However, we see that there exist enough unlabeled questions with which we can comfortably train our models. So when we have 47,000 questions, we can generate 47,000 duplicates with duplicate question generation. Also, we see that the number of accepted answers, which you see in the right column, is also high enough so that we can compare against weak supervision with question-answer pairs. So the goal in the setup is to score actual duplicates higher than unrelated question pairs, and this is measured by area under the curve with a threshold of 0.05 for false positives. And this basically says how much does the true positive rate grow in relation to the false positive rate. And this was the recommended evaluation measure which the authors of the data set recommend. So here are the results. Importantly, we always train a BiLSTM model, and we always use the same number of positive training instances for all the different training methods. So the numbers are comparable and no method has an advantage here. We compare supervised in-domain training, adversarial domain transfer within its best case. Best case means the transfers from a very similar domain, for instance, from Ask Ubuntu to superuser. And we compare weak supervision with question-answer pairs, as well as our methods in the bottom. So what we can see here is that supervised in-domain training performs very well. However, we don't have training data sets for all the domains. WSQA performs a little bit better than adversarial domain transfer in its best case already, but this is not very consistent. It only happens on 2 out of 4 data sets. Our own methods consistently outperform adversarial domain transfer, and WSTB performs a little bit higher than WSQA actually here. The important thing to see is that our methods actually don't require any labeled data, and they already perform better than the other methods that require labeled data, for instance, question-answer pairs or adversarial domain transfer, while being applicable to many more scenarios. However, we have a big advantage here because we can train our models with our approaches on much more data. And if we do so, we see that the performance consistently and considerably improves. We now outperform WSQA more strongly, and even supervised in-domain training with limited training examples. Interestingly, WSTB performs a little bit better than DQG here, and the reason is likely that the BiLSTM learns to handle long text a little bit better, and is directly rewarded in the evaluation setup, where the titles and bodies are combined prior to scoring. So if I would train new models for CQA forms now, if I had enough in-domain duplicates, of course I would use supervised training. In many of the other cases, however, I would suggest, try WSTB or DQG, depending on whether your model can handle long text or only short text. And if there exist lots of good answers, compare against WSQA because it also performs surprisingly well. I want to summarize this talk by showing you what else is in the paper that I couldn't show today because of time constraints, and there's actually a lot. So we have experiments with BERT, so more modern models. We have another duplicate question detection model set up. We have used WSTB for answer selection, a different task. We have applied duplicate question detection generation for low resource scenarios, and some more comparisons. So to summarize, we propose 2 methods to train duplicate question detection models without labeled data. The first is duplicate question generation. The second is weakly supervised training with title-body pairs. And they perform already well with limited numbers of training examples. However, they can often make use of much more unlabeled data. And this makes DQG and WSTB a great option for the large number of scenarios where we don't have access to labeled training data but want to train duplicate question detection models. With this, I'd like to conclude my talk. If you have any questions, feel free to ask them now, and thank you very much.
Thank you. I think we have plenty of time for questions. So any questions?
So what would you do in a scenario where you don't have that separation of title and body?
We don't handle this scenario, so you need other methods. We had thought about this case, and platforms in which this occurs, for instance, Quora. Quora has a large training set of annotated similar questions, so it's not really relevant in this case. Many of the other forums that I showed before actually have titles and bodies, so this is also the case for Reddit, for instance, where people usually write additional descriptions. All of the Stack Exchange platforms have titles and bodies. Yahoo Answers, often some other platforms in different languages, Gutefrage.net, and so on.
Thank you. So any other questions? So actually, I have a question for the generated questions.
Yes.
It's actually very hard to evaluate the quality of the generated questions. So I think you didn't show any results to show the quality of the questions, and whether you have other kind of metrics to evaluate the quality of the questions, say the readability, or whether these questions are real duplicated.
Mm-hmm. So we have only evaluated this on the extrinsic task of question similarity and duplicate question detection. We have not performed a manual or human annotation study. We have a qualitative analysis about this, and but there's no in-depth manual annotation. So
manually,
I don't have empirical results that show that the questions are actually readable, but looking at a lot of examples, I can say they look very reasonable. Often they are without question marks because people on those platforms tend to write titles as not individual keywords, but as sentences. So this is also learned by the model, but it's not harming the performance.
So another related question is that when your method are applied into a new domain, mm-hmm. and in that case, you probably don't have a lot of parallel data, and you only have, say, a bunch of questions, only a bunch of questions. So can you imagine such a case, whether your method can apply in that case?
So when we only have access to few questions.
Yeah.
Yeah, I mean, the duplicate question generation, it can handle the scenario when it only has access to unlabeled questions because it tries to restore the title. If it only has access to very few questions with which you couldn't train a suitable sequence-to-sequence model, it also works. We have explored transferring the duplicate question detection model across domains. So we train it on, say, Ask Ubuntu and apply it to something like Superuser or even Stack Exchange Academia. And the thing is, the transformer model performs bad when the domains are very distant. So when you would train on Ask Ubuntu and apply this on Stack Exchange Academia, the transformer model outputs bad results on unrelated random text, basically, in many cases, but the MQN resorts to copying things from the body, which is actually very stable. So it copies the most important parts of the body and forms them into a question. So we have experiments for this in the paper.
Okay, thank you. So any other questions? Okay, so let's thank the speaker again.